We're going to try to count some atoms and molecules, and to do that we're going to use something called the mole. Now if we want to count large numbers of eggs, we often use dozens. The mole is similar, except that it counts many, many, many more items than a dozen. So we use the mole for counting large numbers of items. And basically we use it to count atoms and molecules. So the mole is equal to 6.022 times 10 to the 23rd items. And that's a big number. We abbreviate the mole as MOL. And this number, 6.022 times 10 to the 23rd, is known as Avogadro's number. Sometimes called N sub capital A for Avogadro. And what it is it amounts to being a conversion factor that converts between moles and numbers of items. So between numbers of moles and numbers of items. And generally those items will be, as I said, atoms or molecules. Let's use it to do an example. How many carbon atoms are in 4.7 moles of carbon atoms? Okay, so we start with the number we're given that we need to convert. 4.7 moles of carbon. We'll put it over 1. We use Avogadro's number as a conversion. Okay, we want to have moles on the bottom, so the 1 mole goes on the bottom. And since we're talking about carbon, it's 1 mole of carbon. On the top, we get Avogadro's number. And that's moles, or atoms of carbon on the top. Okay, and we multiply, we get 2.8 times 10 to the 24th atoms of carbon, because the moles cancel. Now you try a conversion using that same conversion factor, only you're going backwards. Start with numbers of molecules and convert to moles. We'll take the number we're given, 7.11 times 10 to the 25th molecules of CO2. Put that over 1. The conversion factor needs to have the count of the number of items on the bottom because our number of items are our molecules. So we will put Avogadro's number on the bottom. And again, that's molecules of CO2. And on the top, it's simply 1 mole. And that equals 118 moles of CO2. All right, so notice that this conversion factor was the same for CO2 and for just carbon. It did not matter what we're converting. The conversion between moles and counts is the same. It's Avogadro's number. So this conversion factor is the same for all items. And generally that will be any atoms, any molecules, but it could be anything else. Could be bananas, could be porcupines, any counts of anything. If we want to go between moles and counts, it will be Avogadro's number. Now contrast that to mass and mole conversions. If you want to convert between a mass in grams and moles, you're going to need a conversion factor called the molar mass. And that is the mass for 1 mole of a substance. Okay, but that isn't the same for all substances. That is different for all substances. They don't all weigh the same. So That's a difference. It's different for each substance. In contrast to converting between counts of items and moles, like we did for Avogadro's number, which is the same for all items. If you're converting between mass and moles, it's a different number for each substance. Okay, so how do you find that number for atoms? You simply look at the periodic table, and this is a box for sulfur. Now, every periodic table is not the same, so the numbers may be different places in different boxes, in different periodic tables, but the bottom number in this one is something that we know is the atomic mass in AMUs, atomic mass units, but it is also, the exact same number is also the molar mass in the units of grams per mole. And that's what we need as a conversion factor in order to convert between mass and moles. All right, so let's do it for a different atom than sulfur. For sulfur, it's 32.07. For sodium, if you look on a periodic table, you'll find that the molar mass is 22.990. And again, that would be the units would be grams per mole if we're using it to convert in molar mass calculations. Now, different periodic tables will have different numbers of sig figs for their listings, so yours may differ slightly. It may have a few more or a few less sig figs than this one. But let's use this one to do a conversion, and it'll only be good for sodium because this is the molar mass of sodium. So let's do the example, how many grams are in 4.1 moles of sodium. So we'll take the number we're given, put it over 1, and make sure you don't confuse this atomic symbol for sodium with the Na we used for Avogadro's number, where the A was a capital A. All right, the molar mass for sodium is 22.990 grams per mole. Since we want moles on the bottom to cancel, that means the 22.990 goes on the top. So 22.990 grams of sodium per 1 mole of sodium. Do the math and you'll get 94 grams of sodium. All right, now you try a conversion using molar mass. You would do it for argon. You'll need to look up the molar mass of argon in order to do this. All right, we'll proceed. We're starting with 100 grams of argon. Put it over 1. The molar mass for argon you get from a periodic table is 39.95 grams per mole. And we need grams on the bottom. So 39.95 grams goes on the bottom, and 1 mole goes on the top. And we get 2.50 moles of argon. One thing to note is that you do often have a choice of different periodic tables or different numbers of digits in the molar mass, and it's important to make sure you use at least one more digit than the number you are converting. So our number we're converting had 3. 100 has 3 sig figs, so make sure you use at least 4 in your value for the molar mass. So I'll make that comment. Use at least 1 more sig fig than in the number you convert. Because you do actually have a choice in how many digits you use for molar mass.